Okay, I think it's time to start this webinar. Hello everyone. First of all, thank you very much for participating in this webinar, which is concerned with databases, data analysis, and hypothesis testing in the FOT methodology. My name is Dr. Haipo Chen at the Institute for Transport Studies of the University of Leeds. I'm a principal research fellow working in the broad field of intelligent transport systems, urban mobility, and the environmental impact of transport activities. In this FOT Net Data project, we are Leeds is the Work Package 5 leader responsible for updating the FOT methodology and organizing webinars and workshops. Today's webinar is going to be delivered by Dr. Felix Fahrenkrog, whom I will introduce in a minute. Before his presentation, I would like to just take this opportunity to give you a quick run-through of the basic information of this project, such as the objectives and the consortium and the main objectives. Just give you an overall picture about what we have been doing. I'm sorry for those who has heard this at the previous webinars. As you can see on the screen, the FOT Net Data project is a continuation of FOT Net activities with a special focus on data sharing and reuse support. On this slide, you can see the main objectives of this 3-year support action project, which are to support the sharing and the reuse of FOT datasets created in the previous project, develop a systematic framework for sharing and reusing collected data, build a detailed catalog of available datasets and tools needed for managing the database systems and processing the required datasets, and continue to be an international network for informing FOT activities, sharing lessons learned, and promoting cross-border collaboration. So there's an international dimension in this project. This project is constructed in 6 work packages, as you can see in this table. The typical activities include enhancement of FOT network platform, creation of a data sharing framework, specification of data and tools, promotion of the FOT methodology. The webinars are tasked in Work Package 5. So this 3-year project started in January 2014 with 8 project partners, as you can see the names there, and also more than 20 associated partners so far. Work Package 5 aims to enhance and update the FOT methodology with new information about data sharing and data reuse, transfer knowledge of the methodology, and provide hands-on experiences of data reuse. To achieve that, the work package have 3 tasks to do. As you can see here, updating the FESTA Handbook, and also disseminate the FOT methodology, which is what we're doing here, organizing webinars, and also create online learning materials for people, for self-learning, for people who wanted to come back to this handbook and the methodology, and also organize 6 hands-on workshops as well. So next one is in September in Gothenburg, and you will receive information about that workshop. This is out view of the webinars. As you can see, we have done 3 webinars last year, and today we focus on this databases and the data analysis. Just to give you a few quick words about our speaker today, Felix. Felix studied mechanical engineering at the RWTH, Aachen University, with a focus on automotive engineering. And since 2009, he has been working on the development and assessment of driver assistant systems, and is currently leading the active safety team. He has been involved in a European research project such as EUROFOT, with a special focus on data analysis of the field data. Interactive, which is another project, focuses on technical assessment and impact assessment. And he is leading an evaluation project in the adaptive project. So he will give you a lot of insight into the data collection, data analysis, which is rather challenging. Same time next week, we will be doing another webinar with a focus on impact analysis, cost-benefit methods, to be delivered by Perko Rama at VTT. All of you are most welcome to join us. And the materials and the presentations from all the webinars will be used to create a learning material, which will be uploaded to the project website. Finally, if you want to find more information about the project and cooperation opportunities, you can go to the project website, or you can email us with your specific questions. Again, thank you very much for your participation today. I hope you enjoyed it. Before I pass the screen on to Felix, may I ask all of you to think about some questions while listening to the webinar, as we will have a short question and answer session in the end. Okay, now I'm handing the screen over to Felix, just to see how I do it. Okay.
Okay. Thanks, Hypo, for the kind introduction, and hello also from my side. At one point, I have to correct Hypo. I'm not a doctor yet. I'm still working on this. So in the webinar, I will focus on the databases, data analysis, and hypothesis testing within the context of an FOT. Well, the content of the presentation which I will give is implied already by the title. So one part will focus on the database, one part will focus on the data analysis and the different steps you have to do there, and finally something about the hypothesis testing and global assessment. Before I start with the details, I think it's good to have a look in the where these the topics which I'm talking today about are located in the whole process of an FOT, and the FESTA or the FOT Net project has defined in the FESTA Handbook a so-called FESTA V, which describes all processes or different steps which you have to do within an FOT, and this is split more or less in 3 different phases. So first, starting with the preparation of the field test, by describing what is the function should to be assessed, what are relevant use cases, and deriving based on the use cases the research questions you want to assess with your field test. This includes already the definitions of hypotheses and indicators which should be assessed later on, and then once the hypothesis and research questions are defined, you can select the measures which you want to log during the test, and also the requirements for the sensor. The second part of the FOT is the actual FOT, where the car, or where you have the fleet driving in the on public roads, and you collect the data. And the third part is the analysis part, and this is the important part this is the part where the topics which I will talk today on are located. So transmit the log data into the database, do the analysis, and finally answering your research questions by means of the hypothesis testing. And finally, depending on the answers on the research questions, you can set up also an impact assessment in order to investigate what consequences have these functions under test with respect to road traffic, safety, or environmental aspects. And finally, also cost-benefit analysis can be done. These, the second last topics will be part of the webinar next week, as Hypo mentioned. So before we start with the database, I think it's good to have a look on which kind of data can be logged during the FOT. I have collected some on this slide. So you can have subjective data measured by questionnaires, which can be filled in by the test persons at different time points. There are also signals which from the vehicle which you will log, so CAN signals, GPS signals, but also other external sensors like radar sensors, camera information, which are video data. And typically these are logged in a data logger which is in the car, which has a temporary storage where you store the data during the FOT, and later you make them available for the analysis in the database and for the hypothesis testing. Of course, you can also log video data at different positions. It could be a front camera observing the situation in front of the vehicle. It could be a driver camera. This really depends on the needs of your FOT, whether you will have an FOT, a video data or not. The issue with the video data is quite hard to analyze them, and it will generate a lot of data typically. So there's always the question, if you need the video data, but the big advantage of the video data compared to the CAN signals is, the vehicle signals is that you can verify the situations which you log by means of the video data, and maybe get also additional information about the surrounding. So these are more or less the data, and after logging these data in the car, you want to make them available for the data analysis. And typically this is the part where the database comes into play. So the main challenge for an FOT database is to make maybe thousands, maybe hundreds hours of driving manageable from the storage perspective and for the ad hoc analysis you want to do. So the database is more or less are different tables with information which are linked, and therefore you use typically database management systems, MySQL, or a commercial solution like Oracle, but there's also others. And besides to the database management, the relevant question is how to organize these FOT, these database. And this is quite hard to make here really general recommendations to have a recommendation on generic database models, since the needs of different FOTs are quite different. Also the data amount which is logged in different FOTs differs quite a lot. What can be, of course, stated, there's clearly a need for metadata which you need to store in the database. So user added data and certain driving events. Since these data give additional value to your raw information or time history data. Time history data, by this by this is meant to have data which are logged continuously over time, like velocity signals, like velocity, distance to the front vehicle, acceleration signals. The main part, or the main challenge when setting up the database, is really to get these time history data in the database, since these data put high demand on the software and hardware of which you need to use for the database. And if we look at the different FOTs and the databases which have been used, there is the strong recommendation to have these time history data in a single table in order to have an efficient data processing in the database. However, this might be an issue when we talk about storage, but I will come back to this later. Possible other signals which you can store in the database. So one is the ID of trips and the time, which are often used as cornerstones for the database design. So to link different tables, trip ID and time could be one good indice for this. When we talk about time, also a very important part is the sampling rate of your data you want to store. You have to ensure that the sampling rate is high enough to have accurate signals or results, but on the other hand, you have also to take into account the storage. And you don't want to have too much or use too much storage, and therefore you have to find a trade-off between the sampling rate or for the sampling rate you want to store the data in your database. I will come back later also to these examples from EUROFOT several times. If we look there, we had two different sampling rates in the end. We had one at 10 Hertz for signals which changing quite often over time, and for changes which are more, or signals which are more constant, we used a 1 Hertz table. So we had two different tables. Then additional data can be stored in the database and sometimes are also needed. These data are, for example, infrastructure related or weather related data. So if you want to store information about the traffic situation at a certain position, then these data might also need it in the database, and these data are often provided by external entities. So you have to need an interface to get these data in the database, and as I will explain later, also to synchronize the data. Then you can store also transitional data, so about every step which has been done during the data processing and transferring the data. This could be also data to be stored in the database. Here, this is again a bit of trade-off. On the one hand, if you store many information about the processing, you might run into an issue with the storage, and you have a huge overhead. On the other hand, if something goes wrong, these data are quite helpful to get to know what has been gone wrong and at which time point. So again, here it needs to trade off how much transition data you need. If you're really confident maybe on your processes, then you may need less than maybe if you would set up this the first time. Then another very important part, background data on the driver and the vehicle under tests, or which take part in the FOT. Since these are data which cannot locked during, or which is typically not locked during the different trips, and it needs to be linked for the analysis which driver was driving which car. However, at this point, also data privacy must be considered, since it might be not, or if the data are shared between different persons and or different organizations, maybe not all data should be available, especially on the driver, to all people who have access. So at this, therefore also the policy of rights for the database must be taken into account. And then we have events or other classification events we define, or it is typically a short driving situation, like a turn maneuver or a critical driving situation, and you might want to store additional information for these driving events. And you have now two options. You can use a different table for these events and store all information in this table which are relevant to this event, or you store it just as a similar as a signal with just indices indicating whether that event took place or not in the same data table where you also store your logged data. This makes a huge difference when we talk about the analysis in the database. So if you, of course, store the data over time, this might require more space than if you just store the information related to the event in an extra table. However, if you want then to do maybe some analysis with the database, this means if you have it in a separate table, you might need some additional calculation and mapping between these tables, which could lead to a longer analysis in the database later. But this really depends how your database is organized. Some hints which the FESTA Handbook gives, which might be useful when setting up the database. So the first one is quite simple. Each measure should equals one column in the table of database, of course related to the table where you store the time history data. Then one recommendation, if you have video data in your FOT, it's more suggested to have it at a different place, not directly in the database, since this will put a huge demand on resources if you store the video data in the database. Instead, it's suggested to use links. And then there is one thing I already mentioned a bit on the slide before. Some data, like driver ID vehicle, which you can store at a trip table where you just have information which trip took place, when, and with who was driving, could also be stored in the time history table, so where you have the signals. And again, here we have, from storage perspective, this is of course not preferred or not ideal, but if we talk about analysis in the database, this might make your queries a bit more easy and you will save some time when you're doing this analysis. I will now give some on one example from the EUROFOT project where I've been involved. And EUROFOT, I don't know how much you know, so a very short introduction on EUROFOT. So it was one of the first European large-scale field-operated operational tests on in-vehicle systems. We had overall, I think, overall 1,000 vehicles from 9 different vehicle manufacturers on the road. But this was not one huge field test. It was separated in 5 different vehicle management centers, which organized sub-fleets of these 1,000 vehicles. And we had 1 in France, 1 in Germany, or 2 in Germany, 1 in Italy, and 1 in Sweden. And within the FOT, the 8 different ADAS functions have been tested on public roads. So there was adaptive cruise control, ACC, forward collision warning, speed regulation system, blind spot information system, lane departure warning, curve speed warning, safe human-machine interface, and fuel efficiency advices. And in my examples, I would talk mainly on the German 1 VMC, where we had a fleet of overall 132 passenger cars and 57 trucks. This was of 3 different car manufacturers, and from IKA side we had there been responsible to transfer the data to the database, as well as managing this fleet and also to supervise this fleet. We logged for each vehicle around 110 vehicle signals from the CAN bus, including radar information, GPS information. What we had not in the German 1 VMC were video data. I think if you look at the number of 132 passenger cars, I think it's quite easy to understand that it would be high effort to analyze video data. Furthermore, there were also some legal concerns for the trucks. If they drive on a company area, then it might be not possible to store any video data. So we had no video data, and the logging in the car was done by a small data logger from CTEC. And first the data were logged on this data, and then we transmitted to our service via the cell phone net, and then we did the data processing and stored then the data in the database. And with this process, we aim to have a fully autonomous process for collecting the data, so have no driver interaction at all. Everything was done more or less automatically. Of course, you need to supervise and maybe check whether you see some issues during the field test, but there was no direct interaction between where we had our servers, or the people don't have to come back to us and deliver the data. We automatically get them via the cell phone communication. And on this slide, you see the whole architecture, and I have put this slide in the presentation to show you that it's not as easy just to get the data and put them in the database. The whole process could be quite complicated. So when we look at the fleet, so we received the data, and then we needed first an upload processor to collect the data and to identify which data logger has sent which data, and we needed also, we called it Fleet Manager, something which observes the fleet and see what is the status of the SD cards, how much data have been transmitted to our server. And then we had one part which was the central management system here in the middle, which were more or less the brain of the whole process, and ensured that the data were transmitted from one step to the next step. So once we received the data, then we had to do some conversion, do some data checks, and enrich the data with further information. And then finally we stored the data in the SQL database, which we had set up here. We had used in the EUROFOT project an Oracle-based database, but we think it's also would be possible within a non-commercial solution like MySQL. Some lessons learned from the German 1VMC and the database which we had there. So the tool chain which you saw in the previous slide, I think we can conclude that this worked quite well. Nevertheless, in the end, if we would have to set up a database today again for EUROFOT, we would make it a bit more simple. So in the end, the structure which we had was quite complicated. It could cope nearly with everything, but it was not very efficient when we do some queries to this. I know we had one more complex query, and I think the query at least took 1 week, and then it was aborted. So it was not ideal when using. So for simple queries it was fine, but in the end for us it seems to be too complicated, and we would now set it up a more simple way. Also, lesson learned was really to do calculations, whatever is possible, before transmitting data into the database. This saves typically much more time, since calculations can be done much faster in other tools. For instance, in MATLAB, if you use it for data processing, than in the database itself. And furthermore, this is something which I now say, looking back some years, it really needs to figure out to which extent you need the database. The database is good if you want to make the data available to other people and not transmitting the raw data, but if it's maybe just a small, really small FOT with a few vehicles and only one organization is needed, there's really the question, to which extent do you need a database, or whether there are other options, or you can do the analysis by just running scripts over the raw data. So this was the first part on the database. Now in the second part I will focus more on the data analysis. And on this slide, you see the process as it's described in the FESTA Handbook. So you start from the hypothesis you want to test or the research questions you want to answer. And you have first your database. And then the first step, which you typically do, is the data analysis. Building up on this, then you do some processing on the data, calculating maybe some signals which you cannot directly measure. Then you can calculate the performance indicators which you need for the hypothesis testing, which you would do then in the next step. And finally, there's one step which you can do. It's not maybe always necessary, but with the FOT you log only information of some vehicles. We have seen in EUROFOT with 1,000 vehicles, but it's also clear that this does not entirely represent the fleet which we have on European public roads. So there might be some scaling up needed, and this is typically done in the global assessment, and then you can go in the end to answer the hypothesis and research questions on a more general level, and the whole process is combined in the data analysis or included in the data analysis. And if we, well, the FESTA process is more an ideal process, one step after another. If we talk about a bit more about how the evaluation is done in an actual FOT, we have here a bit more simplified illustration of the process. Then, for example, it becomes clear that the data quality analysis does not only need to be done for the FOT data which you get or raw data which you receive. It's also need to be done for the data processing or processed data. This need also to be checked. So it's not a sequential process for all steps, but some steps can be done in parallel, need to be done in parallel. Also the performance indicator calculation, when you're setting up the whole process, it's much more complicated than shown on the previous slide, since you can calculate some performance indicators quite early, because you can do it based on the measured signals, but some performance indicator might be some derived data, so this can be only done in the second or third step. So when we look first on the data quality analysis, different steps which are should be done when you check the data quality I've collected on this slide. So the first and most important one is maybe to assess and quantify whether you have any missing data. It sounds a bit stupid, but it's really necessary. I remember one situation from the EUROFOT project where we found out that we had an issue with the SD cards where we stored the data in the vehicle, and if you can react on this fast, you will not lose too much data, and therefore this needs to be continuously checked whether there's some data missing, but also in the end. And typically this can be done, for example, by comparing the driven distance to the expected driven distance, presuming a certain mean velocity and calculating, multiplying just by the time of the FOT and the number of vehicles you have in your fleet. Then another very important part is controlling data values and units. Typically, example is to mixing up or the units for velocity, whether it's measured in meters per second or kph, but also for steering wheel angle. Typically, it's an important question whether it's measured in degrees or in radian. Typically, this can already be clarified at the beginning or in the dry run of your FOT. It's just really to make sure that you don't have an issue here, especially if you want to derive later on signals based on the measured signals. Then checking data dynamic over time. The example which is mentioned here is if minimum speed and maximum speed of a journey are the same, then the data may not be correctly sampled. Well, this could only be the case for a very short trip. If a longer trip, you have a longer trip, I wouldn't expect this. But another behavior which I remember from the EUROFOT project that we had at the beginning, sometimes at the data logger, a jump to the maximum value. So before the car started or before the car started to move, we already measured a velocity of 250, which is of course not the correct signal. But you need to check for these values that you measure really the correct values and not the wrong values, and this is in particular relevant for the analysis. And then you have to guarantee, of course, that you log the data which are needed for answering your hypotheses. So this can also be checked before, but these are only some of the steps you need to do for the data quality check. And I have another signal which this is also from the EUROFOT in one example, what could be wrong. And you see on the slides two types of signal. On A, you have a continuous signal, could be the velocity or a steering wheel angle or distance. And on B, you have an continuous signal, which could be which are typically status information. For instance, the warning stages. And this is the ideal signal. And when you measure this during the FOT, you will measure the data points at different time points, which are shown now in gray. And if you draw a line between the different points, you get the red lines. So far, everything is fine. But if you now want to move, or the measured timestamp is not the timestamp you want to have your signals on for the analysis, you have to interpolate between and make sure that everything is on the correct timestamp, and this timestamp is now shown in black. And as you can see now, you and for both signals, you can measure or can derive the relevant data points. And if you now draw another line, which would be representing the interpolated signal, then for signal A, you have some deviations, but or differences, but these are not so big. For signal B, it can become really an issue, and 2 points, because now you get a status information which was not actually there. So also for quite simple steps like the interpolation, you need really the data quality checks, and this issue can simply be solved, which you see now on this slide, by selecting a different interpolation method, for instance, the nearest neighbor method instead of the normal interpolation. So the conclusion for the data quality is, on the one hand side, you have really to do your checks for the measured data as well for the calculated data, like interpolating to the results, derived measures, indicators. And it's really a very important step to do these data quality checks and to do them continuously, since the quality of the results strongly depends on the quality of the data. And if you have some faults in the data, this could mean that you have to do a reprocessing of the data, which is typically quite time consuming. The second step in the data analysis, the data processing, it depends a bit how you log the data in your car, but typically you don't log all raw informations direct or store it as raw information. You do some compression in order to save data storage in the car. So the first step typically is the decompression of the data. The next step could be a conversion of the data. Depends again how you set up your data logging. In EUROFOT, we had to convert all signals to a MATLAB format, and in MATLAB then the calculations were done. And the data conversion offers you also the opportunity, or gives you the opportunity to check or to rename signals. And if you have different OEMs involved, this could be a step where you can anonymize to change the name and make not so easy to identify which from which car manufacturer the signals came. Then data filtering, of course, again depends on how well you have logged the data and how well you get the data from the car. Which method should be chosen for the data filtering really depends again on the signal quality, and I think it's hard to give there any general recommendation. What needs to be considered, depending on the method, it could be that there's a time delay. You get a time delay in your signal, which then needs to be considered if you want to derive signals with another measure. But again, this really depends how you set up all the logging and how well the quality is of the data is which you receive from your car. Then further steps in the data processing, you can enrich your data with additional, for example, with attributes from digital map data based on the GPS information, for example, road type, speed limit, curve radiuses. What is important for the data enrichment is that you have to synchronize the data with the raw data which you have logged in the car. This can be done either by time, which is often used, or by position. One issue which we had in the EUROFOT project, for example, were that the GPS signal was delayed often, and by this also you will have no information from the digital map then for the first part where you had no GPS signal. And so you need to synchronize and then have the data available at the right time points. Then this is also the step on the data processing where you calculate derived measures or situational variables. Derived measures are signals which cannot be directly logged in the field but can be calculated based on logged measures. Examples would be the time headway, time to collision. Typically you have the velocity available, the distance to the front vehicle, and maybe the delta V to the front vehicle, and by this you can calculate the time, distance, time headway, or the remaining time to the collision, the TTC. Another example would be the weather status, so you might just want to indicate whether it was dry or wet, and then you can calculate if you have not a rain sensor in your car, maybe by using the windscreen wiper signal whether it was active or not, and derive based on this whether this was dry conditions or more wet conditions. And then the last step is the detection of events. Events I already mentioned are short driving situations which are relevant for your analysis, and examples could be critical driving situations, so incidents, lane change maneuvers, and braking maneuvers. And there are different definitions for certain driving situations, also when a situation becomes critical. And the definitions which you use to detect these situations must be in line with the data quality which you have. So if you have video data, you have the opportunity to verify situations afterwards. So you can maybe use less strict thresholds compared to the situations when you have maybe no video data available and you want to avoid that you have false detections, and you might need a more strict detection for these situations. Again, coming back to the example from EUROFOT, so how was the data processed, organized in EUROFOT? So we had the incoming data from our data logger. They were encrypted and compressed. Then we did some data conversion to and decompressed the files, and so we had MATLAB files then. Then we did the pre-processing where we enriched with the data with the metadata. We called them data afterwards pre-processed data. And then we had MATLAB files with the processed data with the enriched events and PIs, and this was the data which we use now then for the analysis and transferred it also to the database. The performance indicator calculation, you can see it also as a part of the data processing, but since it's so important for the hypothesis testing, we have put it here as a separate box. So what is a performance indicator? According to the FESTA Handbook, a performance indicator or performance indicators are quantitative or qualitative single values derived from one or several measures which are agreed on beforehand and expressed as percentage index or a rate or maximum value, and which is monitored at regular or irregular intervals of the FOT and can compare it to one or more criteria. And typically the basis for calculating indicators are the direct measures, so logged signals, the indirect measures, the events, self-reported measures, for example, if the driver had an incident button, so could mark different driving situations. This could also be used for the indicators or certain situational variables which describe under which situations a trip or an event has occurred or has been driven. The performance indicators are typically compared, first calculated for two phases, the time or the driving without the system, so called the period called baseline, and calculate for the treatment phase where you're driving with the system. And this, what are the baseline and the treatment phase depends on the experimental design of your FOT. Examples for indicators we have on this slide is number of incidents, number of hard braking maneuvers, average speed, or minimum deceleration in certain driving events. This really depends on the hypothesis, what are the relevant indicators for you. And when we talk about the hypothesis testing, so first the definition again from the FESTA Handbook. A hypothesis is a specific statement linking a cause to an effect, and typically it's describing what is the expected or predicted direction of the expected change due to the system, and it can be applied to one or more functions, and it's tested by these different statistic methods. The hypotheses are defined, as already mentioned before, by based on the research questions, and therefore it needs to consider which function is tested, and maybe therefore you have to adapt your hypothesis a bit to the functions you want to analyze. When defining the hypothesis, the FESTA Handbook describes a clear process. So it describes you should go two ways. One is the top-down approach, where you define first which global effect you want to assess and go then down to the system and see whether this is relevant for the function under test or not. And then you have the bottom-up approach, where you go the opposite direction. So first looking what is interesting for your function, and then scale it up to the more general level. Typically, when you're defining the hypothesis, it should involve different areas. It should be a multidisciplinary team. So everybody who is involved in the FOT, maybe you should also involve in the hypothesis, just to make sure that you don't forget something or an effect you want to look at. And this is very important, I think, which is mentioned in the third part or point, that you need to cross-check before you start your FOT the hypothesis. And what could also be part already of setting up the hypothesis is defining the performance indicators you want to assess. This could be explicitly mentioned in the hypothesis. One example we have on the bottom of the slide. This would be the function will increase the minimum time to collision, and the part which is often not mentioned in the hypothesis, but what is meant is compared to the drive without the function. So it's clearly stated that for this hypothesis, the minimum time to collision should be assessed. The counter example would be the function will increase the lane change performance. So for this hypothesis, it's not stated in which way it should be measured, whether the lateral acceleration is a good indicator or whether it's the steering wheel. So this makes it a bit harder then to select the adequate indicators. The typical approach for the hypothesis is similar to the scientific approach. So just really the main steps, first steps I have explained on the previous slide, is to define the relevant null and alternative hypothesis, and then decide which is the statistic test you want to apply. Is it a ANOVA or a t-test? ANOVA would be the case if you have more test groups. T-test you can do if you have only 2 groups. Then you have also to select this level of significance you want to test. Common values are 5% or 1%, so to decide when do you reject the null hypothesis in favor of the alternative hypothesis, or you don't reject the null hypothesis. Criteria which can be relevant for your hypothesis. We had already the comparison between the baseline and the treatment phase, so these are typically the 2 phases which are compared, but in principle it's also possible to have more phases. So a first treatment phase, so the first contact with the system, and a later contact or the behavior over time after the user gets familiar with the system. You can also consider filtering criteria, so your analysis focus only on vehicle speeds above 50 kph, or only you select drivers which have driven in the FOT a minimum mileage of a certain amount. Furthermore, you can limit your analysis to, or have only a look at certain driving events. So you just compare the minimum time to collision for motorways, or in rain, or in dry conditions, or at day or night. So this can also be considered in the hypothesis testing. Performance indicators, well, I think it's clear that you can consider here different ones, and it really depends on the hypothesis you want to answer. And also you can maybe have differences in the user set. So the question is, well, whether you have always to use your full your full data set, or maybe you just have a look on males, females, depending what you want to assess. One approach which is often chosen in FOTs is the scenario approach. Therefore, I have it on the right side. So you do the analysis for a certain scenario, and the scenario is always meant to have one driving event. So, for instance, a car following situation, and describing also the situation variables. So the example would be here shown on the slide: a car following event at night in high traffic density on a motorway. So you have considered 3 different situational variables as well as one event, and together this is often called scenario, and this could also be used for the hypothesis testing. The last part, the global assessment, as I said before, this assessment deals with the issue to identify models and methodologies to scale up the results of your FOT, which represent only a small part of the European traffic, to a more global or European level. And this is typically done for traffic safety, environmental effects, and traffic flow. And we have here already a slight overlap to the impact assessment. And the issue which you're facing is how to generalize the results which you have measured or find out in your FOT. And typically there are 2 approaches, and the first one is that you have go directly from your results or PIs to the level of fact, so that you make some assumptions. What are the consequences, for instance, of increasing the speed for safety? The second approach would be to have a scaling up of the FOT results by using a higher penetration rate or larger regions, and this is typically done then by simulations. And we have both approaches again here on this slide. So the first one now in the red box shows the first approach. So you have your FOT data, you do your analysis, derive your PIs, and then you make some assumptions or presume some driving patterns, and then describing already what is the direct effect for traffic flow, environmental effects, or traffic safety. The second approach is the one which is more focusing on the scaling up. So based on your FOT data, you derive driving behavior and models for the driving behavior or distributions you have logged during the driving, and then you apply these driving model and distributions which you have logged to micro simulations and run again these simulations with different penetration rates, maybe also different car types or in a different network, and then do a detailed analysis which effect you see based on these simulations. And of course this can also consider accident data types, then we are clearly in the safety impact assessment. So some lessons learned from the data analysis. Really important step before the FOT, check really whether the selected data set is with the selected data set is feasible to have the analysis which you should do. Often dry run is conducted, and really it's really good to have a more clear or detailed look at these dry run, not just checking the logging of the data, but also check already data quality and ensure that everything is there in the right quality. From our perspective, at least the experience from the EUROFOT project, it's really good to try to automate the process of the analysis as far as possible. It makes your life much easier in the end if you have an automated process, in particular if you find out that there is an issue with the data or there was something going wrong and you need to do a reanalysis of the data. Then automations has clearly a benefit. Also, it might be some more effort required at setting up these automated processes. And then video data analysis, I haven't mentioned it so often, but it's really, it's quite time and resource consuming, but it has a clear advantage that, or gives you the clear advantage that you are able to verify the situations, and by this maybe reducing also false or wrong detected situation. And issue which you really have to take into account is synchronization of data if you have different data sources. So, and with this, I'm more or less at the end. So I hope I could explain a bit to you the different steps, including databases, data analysis, research questions, and hypothesis testing. And if you want to know more about the analysis, the impact analysis, our cost-benefit analysis, there will be a webinar next week focusing on these points. So thank you very much. And I don't know, are there any questions? Or Hypo, how do we continue?
Okay. Well, thank you very much, Felix. Thank you very much for this very informative presentation, which combined the standard issues from the FESTA Handbook together with very detailed examples as well. So we can see the issues, but also we can see how these issues were addressed, at least partially, in your project. So thank you very much for that. I just want to ask the attendees, there's any questions from you? I guess everybody can talk, is that right? Yvonne, have you unmuted everybody?
Everyone is muted, so you can raise your hand. But we already have a question from Guillaume Autret. How is logged the position of the position system?
Sorry, once more?
Guillaume, I've unmuted you. You can pose your question yourself.
Yeah, hello. I don't know if you hear me very well. I just want to know how the precision of the vehicles are logged.
In the EUROFOT project, we used the GPS, standard GPS system for logging the position, and the position was then stored in the data logger and transferred together with the other raw information to the server, and there we had the map matching with the digital map data to get the additional information from the map.
And which kind of map do you use?
The map in EUROFOT was provided, I think, by Navtech.
Okay, thank you.
Okay, thank you very much for that question. Any questions? Any further questions?
Yeah, we have a question from Gideon.
Okay.
Maybe you can pose it yourself, Gideon?
Yes.
Your sound is a bit difficult. What Gideon said is the performance indicators are not completely independent. Is this something you could consider at the level of data analysis or impact analysis?
Yeah, this is correct. If we take, for example, the lane change performance, there's of course a link between if you have a steering wheel angle and the acceleration. So I think you should already consider this at the hypothesis testing level, but also, of course, at the impact assessment level. Since if you want to derive what the consequences of the behavior which you see on the field, then of course, if you take both signals, it's some kind of redundancy between these signals and similarity. So it should be typically enough to have one. And depending on the data quality, maybe which is you have, or which you are in the test, which of the logged signals, you should decide on which indicators you are going for. So it's not only the indicators which are implied by the hypothesis, but it's maybe also good to have more than one indicator, possibly for one hypothesis, and decide on the data quality which one is maybe the preferred one.
Okay, I think we can afford another, just one more question. Yvonne, have you any questions from the audience?
No.
Okay, can I just close by ask a very general question? You mentioned the challenges of storing the FOT data in a generic database model. I was wondering why we needed to have a single generic data management system. Because nowadays people are talking about big data, cloud data management. Can FOT data be stored in different systems, but there's tools to bring them together?
Well, of course you can bring them together. You need then to define, I think, a common data set. But what I meant with the slide and generic structure is it's really hard to have a common structure first in place and then to say or have a solution that works for every FOT, since demands and the logged signals typically are quite different in the FOT. Some have video data, some have no video data. And maybe just going back to the EUROFOT, we did already, or this database structure which has been used was not only used in the German one VMC. We had a close cooperation with the French VMC, which had video data. So we considered already some approaches to have a more generic approach, but that typically makes it also quite complicated, and then you might run into performance issues.
Oh, I see. Okay. Anyway, I think the time is up now. Thank you very much, Felix, for your wonderful presentation, and also thank to everybody who is here today. I hope that we can talk to each other same time next week. Okay, bye-bye.
Bye.